Hello everyone. Myself Anujay Pampali. I'm a student of Lovely Professional University, currently pursuing BTech CSC, specialized in AI and data engineering. So today we're going to dive into the world of data structures and I'll be explaining about the stack data structure in Python along with its implementations. So what is a stack? A stack is a linear data structure that follows the principle of last in first out, which is also known as LIFO. So whenever an element is added inside the stack, it is added on the top of the stack, and the element can be deleted only from the top of the stack. So basically, a stack can be defined as a container in which the insertion and deletion of elements can only be done from one end, which is the top of the stack. So the last in first out, which is also known as the LIFO, is basically a principle in which the topmost element, which was added the last, is removed from the stack at first. Then the second last element, is removed, and it goes on like that. And finally, the first element which was added to the stack is the last element to be removed from the stack. Now let's take a few examples. Suppose we take an example of books. So in a stack of book, uh, suppose these are a few books. If we need to take any one of these books which are under, we need to first remove this book from here. Then only we can take any one of these books. So that is how stack works. So stack is used for developing efficient algorithms, managing function calls in a program, performing recursion tasks, and many more. Now let's move on to the basic functionalities of a stack, which are push, push, pop, p is empty, and finally the size. So the push operation is used to add or append an element into the stack. The pop element is to delete or remove an element from the stack. The peek operation is to see the topmost element in the stack. And the is empty is to check whether the stack is empty or not. And finally, the size operation is to see the number of items which are present inside the stack. Now let's move on to the coding part. First, we begin by creating a class called stack. Then we define limit self.items. We create an empty list. So this is to initiate the class. Next, we have define is empty. Turn len self.items equals 0. So this is to check if the stack is empty or not. We define push self item self dot items dot append. And then we have defined pop. Now this push is to append or add an element into the stack. We're defining it. Then we have pop if self dot is empty, return stack is empty. So here we're giving a conditional statement, which is if the stack is empty, then we have to return the output as stack is empty. Else we have return self dot items dot pop, which is to pop the final element. Then we have defined peak. It's the same as the pop. If the stack is empty, we have to return that the stack is empty. Else we have to return the top element, which is self dot items, and we have to give the indexing of -1. And finally, we have the size of the stack. We return length of self dot item. Now, since we are done with the defining, let's move on to the demonstration part. So first we give stack equals stack answers. Then we push a few items into the stack. Push 10, stack push. So here we have pushed three elements, 10, 20, and 30 into the stack. Now let's print the stack items. When we run the program, we will get 10, 20, and 30 inside the stack. Now let's check the size of the stack, which is stack dot size. When we run the program, we get size equals 3 as there are three elements in the program. Now let's pop one of the last element. So when we enter this, the last element which was added, it's 30. So the number 30 should be deleted from the stack. And let's again print the items in the stack. Stack items. Now when we run the program, we can see that the number 30 was deleted. So the remaining numbers are 10 and 20. Let's again pop one of the items, and we can also show the uh, item which was popped. So item popped equals stack dot pop. When we run the program, here we can see item pop was 20 because that was the second last element which was added. Now, since 20 is popped, now the remaining element is 10. Let's check whether the stack is empty or not. If we run the program, sorry, not the parentheses over here. Yeah, it appears false because the element 10 is still there in the stack. Now, let's pop the final element inside the stack, and let's check if the stack is empty or not. As you can see here, true was given, which means that the stack is empty. So here the Boolean function is involved. Now, before popping the last function, we forgot the peak operation, so let's try that out. Print stack dot peak. Yes, so once we run this program, the number 10 appears because that's the only element, and it is the topmost element which is present in the stack. Now, let's again pop the final element, and let's again check peak the top element. Now, as you can see, it shows that the stack is empty because the last element which was present inside the stack has been popped and it's been deleted. So these are the operations which can be done to a stack. Thank you for watching.